Hi, this is Gabriel from mastermathcourses.com. I wanted to explain the website for just a bit. The website looks like this. I have the main video, just like the one you're seeing right now, and I also have frequently asked questions at the bottom. Those are video responses that I've answered to other people, and I put them underneath the main video. I also have a button that says Ask Questions, and you can ask questions there. I do what I call educational walkthroughs. Educational walkthroughs are walkthroughs that begin from beginning to end and seem like a story, and this story is educational in that it describes the mindsets that you want to have, the reasons why I'm doing things, and following up with video responses. So watch this video from beginning to end so that you get the most out of this walkthrough.
Hi, it's Gabriel, and today we're going to walk through another problem. This problem says this: find two numbers whose product is 100 and whose sum is a minimum. It's an optimization problem, and we're trying to optimize the sum of these two numbers whose product is 100. So the first thing we do is we come up with our two formulas. In this case, we're dealing with sum and with product. So we're gonna use those two formulas, and the 100 goes where? Well, the 100 is the product, so the 100 goes in this spot right here. So I would have 100 is equal to x times y. And remember, when this indicates to us two things. One is that we need to rewrite that formula. We need to rewrite this formula in terms of and solve for one of the variables. The second thing it tells us is that we want to take the derivative of the other formula. So the derivative of the other. So I'm going to take the derivative of this, not that. But first, I need to rewrite this and solve for one of the variables. So let's say I wanted to solve for y. Then I would have to divide both sides by x. And I would get that 100 divided by x was equal to y, because these two x's would cancel. Now what do? We plug this number back into the derivative. So I'm going to have 100 divided by x replacing this y value. So I'm going to have s is equal to x plus 100 over x. So now you see everything is in terms of x. So now I could take the derivative of that. I would have s prime is equal to the derivative of this would be 1. I can rewrite this as 100 times x to the negative 1. Right? So I'm rewriting it to look like this, but it's really that. Why? Because I want to use the product rule. Now I can use the product rule. A negative 1 times 100 is negative 100, and then I could decrement the power by 1, which would bring it down to negative 2. Now I can set this equal to 0 and find the two critical points. 100 over x squared. I'm setting it equal to 0 because I want to put it into my number line. And what I'm looking for is, since I'm looking for a minimum, when does a minimum occur? Well, a minimum, let's write it down over here. When does a minimum occur? If we think about the derivative is an indication of slope. So if you imagine a roller coaster, you would be decreasing first and then increasing. And that would indicate a minimum. That would indicate the value of the roller coaster. So we want a situation like this. Let's find our critical points. How do we find the critical points? Well, this is a rational equation, right? Because you have an x squared down here. A rational equation, again, is rational, the keyword being rational is a ratio where the value at the bottom is typically an x. So when that's the case, one of the critical points is going to be 0, because a critical point happens when f prime, the derivative, is undefined and when the derivative is equal to 0. So we know that that's one of our critical points. We also need to find our other points, and that is by solving this for x. So I would multiply. This is a rational equation. To solve a rational equation, I need to multiply by the LCD, which would be x squared. I need to multiply everything by x squared. What would I get? Well, x squared times 0 is 0. X squared times 1 is x squared. X squared times negative 100 over x squared is just negative 100. And I could solve for that. This is a quadratic equation, so I can add 100 to both sides. These cancel, and I'm left with x squared is equal to 100. I want to stop here and I want you to notice something. We started off with this type of equation, which was a rational equation, but then we turned it into a quadratic equation. So this right here is a quadratic equation to find two other critical points. So these equations aren't going to be static. You're not going to start off with a rational equation and it's always going to be a rational equation. It's going to switch up on you, so that's going to make it a little bit difficult. And if you followed my videos, one of the things that I teach is putting on a hat. So putting on a hat just represents to me kind of like putting yourself back into that when you were being taught that particular subject, like rational equations. Whenever you think of rational equations, you're thinking of everything like LCD, multiplying everything by the LCD so you clear out the denominator. If you put on your quadratic hat, then all these memories should pop up about, okay, so I could factor, I could use the square root property, I could also, one of the other things that we can use is the quadratic formula, which is the x is equal to negative b plus or minus b, the square root of b squared minus 4ac divided by 2a. But those words can be attached to a lot of meanings. And when you name it, you're able to kind of like recall more of the information that you were being taught at that particular time. So they almost become kind of like little anchors where when you say this name to yourself, you're like, oh, quadratic equations. Yes, that's right. We factor. And that helps you out a lot to kind of like stop and say, wait, well, what type of problem is this? And then once you decide, oh, it's quadratic, so let's put this hat on and then do it like that. What we're doing here is, what we're working here with is a quadratic equation where we move the 100 over. One of the things that we can do with quadratic equations is we could take the square root of both sides. So that we call that the square root property. And I can do that as long as I put a plus or minus in front of the number. So plus or minus the square root of 100 is equal to the square root of x squared. And this cancels that out. That's one of the properties of quadratic equations. So that follows that x is equal to plus or minus 10. So those are going to be my two other critical points. So I'm going to have negative 10 somewhere over here and positive 10 over here. Those are our critical points. And again, we want a kind of like a decreasing slope and then a positive slope to see if it's a minimum. And to figure out when that happens is we need to test these regions. A, B, C, and D. So a number that is less than 10 would be negative 12. A number that is between negative 10 and 0 would be negative 5. A number that is between 0 and 10 would be 5. How about, you know what? Let's use 1, right? That should be easier. And 12. So let's think about what's going to happen if I plug it into my derivative. This is my derivative. Let's go ahead and scroll down some. F prime of some number is equal to, this is my derivative right here, which could be represented by that 1 minus 100 divided by x squared. And I'm going to leave a little spot here so that I could plug in a number. And my test points go here. Like negative 12 and negative 12 here. Well, what happens if I square negative 12? That's going to be 144. 100 divided by 144, since the 144 is larger than the 100, this is going to be less than 1, so this is going to be positive. So I'm going to be upward sloping here. So I'm going to be upward sloping here. If, let's say instead, I change this to a positive 12, well, that's not going to change the sign of what's going to come out of here, because this is still going to be a positive 144. This is still going to be less than that. So it's also increasing from, at this test point, which is from 10 to infinity. So it's also increasing here. Now we need to test the other 2 points. So I'm going to have f prime of some number is equal to 1 minus 100 over some number squared. And I'm going to test the points negative 1 first, then positive 1. But first, if I plug in a negative 1 here and I square it, that's 1. This means that this number is going to be larger than 1. So since this number is negative, the result is going to be negative. So I'm going to be decreasing from negative 10 to 0, decreasing from here to here. If this switches to a positive sign, that sign isn't going to change, so this is still going to be positive. This is still going to be negative, and it's going to be a larger negative than this one, so it's decreasing from here to here too. Well, let's look at this now. Notice that at this point right here, when we're going from again, let's imagine a roller coaster, we're increasing. So we're kind of like going up the roller coaster, then we plateau. What is that called? That's a maximum. So that's no good, right? I don't want negative, the maximum. I want the minimum, which would occur right here. Because at that point, I have the situation that I was talking about over here. I'm decreasing and I'm increasing. So we found our point, which is our x value. So one of our numbers is x is equal to 10. So what does our other value have to be? We know that the product was 100. So 100 times y is, 10 times y is equal to 100. What does y have to be equal to? 10, right? So that's what my y value is. I hope you liked the walkthrough of this problem. And if you'd like to see more of these problems, you could go to the website, mastermathcourses.com, or you can also go to Facebook. Sometimes I put the videos up there, and you can know when we have new videos. So hope to see you soon. That wraps it up. So don't miss the opportunity to have your questions answered at mastermathcourses.com. So click on the link in the description section.